So I started my career, like a lot of us do, on a help desk. People would ring me up, I would fix their computer. Maybe the screen stopped working, maybe their internet connection dropped, maybe their email client was playing up. Largely it was straightforward. They'd talk to me, I'd talk to their computer. I was really just an interpreter until one day it all changed. I had a call from one of the executive team who was having trouble accessing one of the share drives. And see, in those days we had our own file servers. At the time, cloud storage was really only used for rain. But each morning when you logged into your system, a script would run, and it would, based on who you were, it would run a bunch of commands, and it would map your local machine to the server. And that would give you access to your team's group of files. You know, there was an all company one, there was your team. It was all an amazing system. But this guy was having trouble getting into his team's set of drives. In fact, he had trouble getting into any files at all. So I checked all of the normal things. I checked that his user was set up right. I checked that that the scripts were attached well, they weren't buggy, and I initially just assumed it was kind of a misunderstanding between the identity server and the file server. I would explain things to the server and things would be made well again. However, I looked up his profile, it was fine. I looked up the scripts, they were fine. They were working for other people. There were no bugs. I tried everything logical, and what happened next would change my career forever. I confided in a colleague. I was fresh out of ideas. I said, I can't think of anything. It's all looking fine. And my colleague sat there thoughtfully. He was much older than me. He'd been working in tech a very long time. And he said to me, "What about PebCac?" And I said, "Excuse me, did you sneeze?" And he said, "Just go and watch him. Watch him log in." He gave me this knowing look that old people in tech give you. And so I wandered over to his desk and I said, "I'm going to need you to kind of shut down and restart and just kind of log in again." And he gave me that look that executives give tech support people, like, "You're getting in my way. Why can't you just get this right the first time?" And of course I was inexperienced, so of course I apologized for being in the way and fixing his problems. And so I said, I'm really sorry, can you just log in again? And so he shut down his machine, he waited for it to close, he opened it up again, and I started watching like a hawk. I watched as the login page appeared. Yes, that's supposed to happen. I watched him type in his username, I watched him type in his password. I didn't mean to watch him type in his password. But I watched him type in his password. It was very close together. 1, 2, 3, 4, 5, 6, 8. Because he's serious about security. And then I waited with bated breath as the login box disappeared and the boot sequence started. The login boot sequence started. As expected, the black box popped up. The terminal that was going to run my scripts. I was all excited. And what happened next changed my life forever. As soon as this terminal box popped up, he whipped up with his mouse and hit the X, terminated it mid-launch, spun round in his chair and said, "And that's another thing you lot need to sort out. That pops up every day and I have to close it." I floated back to my desk, dazed. "PebCac?" my colleague asked me. I'm like, "What does that even mean?" He said, "Problem exists between keyboard and chair." Now, I didn't really know what he meant. I didn't really at the time think about my users as problems, but it was a really good explanation of this fine line we walk. As we work with tech, we realize that tech is not our biggest problem. Tech is not our most complicated problem. Tech is the easy bit. It's the people that we need to learn to navigate. So that's where kind of this idea starts for me. DNS, it's a long reach. Walk with me on this. DNS is one of those pieces of technology that kind of sits in the real world and helps connect real people to the rest of the tech that we do. So DNS is one of those things that we maintain in order to help our users remember words, remember phrases, and integrate their lives into this technical world. So that's why I wanted to talk, well, one of the reasons I want to talk about DNS. The other is we often don't return to the basics with tech. We often, we get tied up in our own tech and we're tied up in our own tooling, but we forget a little bit of kind of the construction of the internet. There is a wonderful world of DevOps that we all benefit from, but it doesn't give us the right as developers to ignore the mechanics under the hood. So DNS is what I want to talk about. But first, welcome to Abletech and Address Finder, the global HQ of. This is where we do the work of wrestling with the problem that exists between the keyboard and the chair. We tend to call them clients, but at times they are problems, at times they are wonderful people that are trying to kind of connect their world to technology, and we support them in doing that. My name's Ross. I'm a solution architect here, which means basically I get to take credit for all the things that go well, and when they don't go well, I get to blame implementation. That's actually not how it works here. Most of the time, I'm not responsible for anything that goes well, and when things go wrong, it's generally because I forgot to think of something. But if the first definition of architects is your experience, I'll remind you that we're hiring. I'll leave that there. So what is DNS? Let's think a little bit about what's under the hood in the technology we use. What's it for? How does it work? DNS is it's the phone book of the internet. Now, it's how we get words into numbers. It's how we navigate the internet. Now, just show of hands, who here is familiar with DNS? Who here maintains DNS records on the regular? Oh, less. This is good. This is good. Who here couldn't care less about DNS, but they're here because we're hosting? Right, so what I want to do is I want to start at the very start. How does DNS work? What is it? What does it look like? So the idea of DNS is to take words and use them to find our way into internet services, into websites, into emails, into kind of the whole broad range of services that we offer on the web. So the way it starts, you type a URL into your web browser. And this is what happens. So that's a user query, and that's handled by what we call a DNS resolver. So a DNS resolver's job, it's usually provided by your ISP, your internet service provider. Its job is to kind of walk this hierarchy of DNS. It's a distributed protocol. It lives in different places across the web, different geographic locations, optimized for performance. But the DNS resolver's job is to navigate that infrastructure. So it starts with its local cache. It works out whether it can answer your query. If not, it goes further up the chain. Where it goes to next is a root server. So a root server's job is to kind of work out where are you going next. What's the top level domain you're going for? Because where this all started was a domain name. So a domain name. You purchase, it's more of a rental process, but you purchase your domain. We say purchase, but the purchase gives you the right to control who looks after the services for this domain. So we're working our way through this process to try and find out who's in control at this point. So the root server's job is to say, well, what kind of domain is this? Is this a .com? Is this a .nz? Who do I send you to next? So once it's worked out this kind of what we call a top level domain, it'll send you up the queue to the top level domain server. Now I think there's 13 of those across the globe that kind of are responsible for these top level domains, and who is in control of those records. So it sends you off to this top level domain server. So say in this case you've got a .net one, a .nz one. It'll send you off to the authoritative name server, or it sends you to the top level domain for .nz, and its job is to know who the authoritative name server is. So who's responsible for all the services attached to this domain? So the authoritative name server is basically what you've rented. So you've rented space on that server to say, these are the services I offer at my domain. So once you finally arrive at that, the authoritative name server, or just the name server, it has all of the answers to the questions. Now, all the way through this process, there's caching involved, as you'd imagine. So some of these queries are incredibly fast, and some of them, when the records are new, they can be a bit slower when they're changing. So it's one thing we've got to manage a little bit, is when we make a change right back here at the authoritative name server, or with the records that it holds, we've got to wait for that that process to expire all the way back up. So let's say you were looking up an IP address. I'll talk about in a second what that looks like, but you end up with your IP address, and then it chunks its way back down this chain, back to your original query maker, which in this case could be your browser, and it says you've got to connect to this server. So at that point, we're outside of DNS. We're back in TCP IP land. We're connecting to servers on ports, and we're making requests over protocols like HTTP. So we won't go into all of that stuff. We'll just stick to DNS. Any questions at this point? I know that was really fast, but the most common record you're going to end up with. So back on this, you've got this authoritative name server. It's responsible for holding a bunch of records. These records represent services your domain offer. In some cases, that's IP addresses. In other cases, which we'll talk about, it's a little bit of dereferencing and pointing around the web. So the most common record you might have is an A record. So this is, or a four-way A record. So an A record will point your domain or some part of your domain. You can have subdomain, you can put bits off to the left there. This will point at an IP address. So just a regular IP address. So this is as simple as it gets. We used to only use www for this, but now we do it at root level. We do it all over the place. But say you did www.abletech, you would get this IP address that would tell your browser, connect there, fire some HTTP protocols at it, and you'll end up with what you're after. In the case of IPv6, it's a similar idea. It's just got 4 A's for the record. Much less common. It was a really big thing for a while. We all had to be IPv6 ready because we were running out of IPv4 addresses. We were in dire straits in tech world, much like Y2K. It didn't actually turn out to be as big a problem as we thought. The price went up a little bit, and everyone was happy again. But Address Finder has it enabled. I don't think Abletech actually does, but Address Finder is all sorted. It's actually a very cool infrastructure, the way IPv6 works. Talk for another day. CNAME records. These are a little bit different. These are the way you point one domain or subdomain at another subdomain. So we use these a lot as developers when we're using kind of third-party services. Heroku was probably the big flagship that started raising people's awareness of this. But if you use Cloud66, if you use DigitalOcean, even they're all kind of giving you pre-existing domains of their own or subdomains of their own that you can point your stuff at, and we can use domain aliasing and things to make that work. But so in this case, we don't do this anymore, but we used to use one of the many blogging platforms. They'll give you a URL, and you can connect your subdomain to that with a CNAME record, and everything just works. MX records, these are for your mail servers. We don't tend to run mail servers anymore. If you do, that's great for you, but I think you could find better things to do with your time. We tend to point it at Google or some other places, but MX records are how you announce to the world how to send you an email. So what happens is an email client will look up your MX records. There's a hierarchy of them. There's priorities, there's fallbacks, but in its simplest form, it's really just when I want to send mail to Abletech, I need to hit up that server. And same deal, I hit up that server. I see again this MX record often looks a little bit like a CNAME. It's a domain to a domain, and then that will eventually resolve to an IP address that we can connect to and use an SMTP protocol. Text records is where kind of the most expansion in the last kind of 10-15 years of DNS has gone. We use these for all sorts of purposes. This is how you verify that you're in control of this domain so that Google knows that it can happily host mail for you. It's how you do some of the more high security things, like prove that you are allowed to send mail for this domain. So a lot of modern spam checking really requires your SPF and your DKIM records to be set up properly. And that's just a set of text records that servers that are going to relay your mail can go back to and check and go, yeah, is this all legit? In fact, if you are sending emails from your apps and they're not arriving at their users, that's probably why. It's the most common thing I'm doing with text records at the moment. Name server records, DNS records, these are the ones that set up. I've purchased this domain, I'm in control of it, and I want to host my records at a particular location. I really recommend that when you get a domain, you don't go with the services of your registrar. Oftentimes, say you're using email with your registrar, if you want to make some changes to your mail records, they'll delete your mail services as you change them. It's a real hassle. So you want to keep them in separate places. Have your domain registered over here and have your records over here. So your name server is how you worry about that. Pointer records, this is a real tricky thing to work with. I don't recommend spending any time at all unless you're going to spend a lot of time looking into pointer records, but these are the ways that mail servers validate the IP address of the server that they're transferring for. So if you're like a mail exchange where you're passing mail on for someone, you can often say, well, if it came from abletech.nz and it came from this IP address, is that legit? So it's another layer of checking. But again, if you're doing that checking yourself, you need a hobby. So how do we interact with DNS? How do we debug things when they're going wrong? Dig command is how you do it. NS lookup is what you'd use on Windows, but a dig command is a local DNS client. It can query your DNS resolver and kind of ask for different information. So this is the way you would do that. A dig command to Abletech NZ and the type of record that you'd like to interact with. So A, NS, MX, any of those. There's a bunch of other things you can do. You can force it to, with the @server is probably the most common one I use on the end there, that you can query a particular DNS server if you want to, if you want to work your way through a hierarchy or something like that. Dig is what you're after. There's online tools as well. Google's got a really good one. These are the two I tend to use the most. MX Toolbox has got a bunch of different tools there for looking up what records are and how they're set up. But the DNS propagation checker is another one that it's really helpful. As you make changes to your DNS records, the records themselves have a timer on them, which essentially cue DNS servers on how long they can hold on to that information. They should be adjusting their cache times based on these. They're called TTLs, or time to live. They don't always do that, and you can monitor DNSs around the world with this propagation checker and see, I made this change, what does it look like in these 15 different DNS servers around the world. And it's, particularly if you've got a global product, you can see why some users are able to access your services and some aren't. If you want to talk more about DNS, the biggest place that DNS has changed in the last few years, or the last decade probably, is in security. DNS is an unsecured protocol, so you do need to watch out for ways that can be vulnerabilities in that process, ways that people can modify your interactions with your DNS servers and have a great time at your expense. So some extra things to look into if you're interested: DNS security, DNS over HTTP or TLS, all the usual suspects for how we add security to things. Another really interesting protocol is the Anycast DNS. It's not DNS, it's actually a way of having a global reach with your IP address. There's all sorts of cool border gateway protocols that allow you to have the same IP address in different locations in the world. So you might be familiar with the DNS server 1.1.1.1. That is who was it? CloudFront run that as their DNS, but it doesn't mean a single server. It's a distributed IP address using Anycast protocols. It's well worth a look. So as a check to see if you were listening, to see if you were paying any attention at all, the greatest quiz since Hot or Not is DNS or not. First, it's always DNS. Well, we'll see. Localhost. That's a host name we use a lot. It maps to 127.0.0.1. It's your machine if you're interested. Is this DNS or not? Yeah? This is not DNS. This is your local loopback interface. Your host file is responsible for it. So /etc/hosts. If you're on Windows, I think it's C Windows System 32 drivers, etc. host. They keep it really handy if you need it. All right, another one. myserver.local. DNS or not? It is? It is not. This is multicast DNS, which we call DNS, but it's DNS that you use when you don't have DNS. This is also like the same protocol that Apple calls Bonjour and pretends that they have invented a whole new language or protocol. It's actually just multicast DNS. File server, hostname resolution, DNS or not? I think you're catching on. This is a local link multicast name resolution. So when you kind of do a ping to a host name on your local machine, there's actually 4 or 5 or sometimes 6 different protocols that try and work out the IP address for you. DNS is the first one, so they'll all go to DNS, even though, like, for those of you that are watching closely, there's no top-level domain on that. .local isn't a top-level domain, so it should be able to do it with some beautiful regex, but it doesn't. It just sends it to DNS, it fails, and then it goes to the next one down the chain. But that's like, who's old? My computer dollar. Can you recognise that? DNS or not? No, it's not DNS. It's a NetBIOS name service. That's mainly a Windows thing, but actually even Macs still query that for Samba shares and that sort of thing. So if you've ever had to support a designer who works on a Mac, is the only person in the entire government department to have a Mac, and they have Samba shares to the file servers. Dropbox was the best thing that got them off NetBIOS. How about this one? No, it's not DNS either. Watch Mr. Robot, that's well worth a look. How about this one? Yes, that one's DNS. That was the only DNS. So it was really not DNS quiz. But yeah, that's all I got for you. I hope that you now are really in love with DNS and you would like to use it a lot more, write DNS records, set really short TTLs so you can change them as often as you like. Any questions? It's a whirlwind tour. I can get that. No? That's fine. I think there's pizza. Let's do it.